All right, so this is trig functions and angles number 3. Sorry, I just hit the record button. We just labeled a triangle that is in the coordinate plane with an angle that's faced from the center, and labeled the opposite, the adjacent, and the hypotenuse, and what it would be if we had a coordinate. This would be the x side because it's going across, the y side up and down, and we call the side that's the hypotenuse an r. And that's how you figure out what r is using the Pythagorean theorem. Okay. And now we're just writing what the trig ratios would be using x, y's, and r's instead of o's, a's, and h's. That got you caught up. When you are finished with these 4 trig ratios, make your best silly face into the camera. That's good, Dalen. I like that. If y'all aren't too cool for school, you can make a silly face in the camera. That was good, Marlene. I like it. All right, so let's go make sure everybody got the right thing written down so you don't have the wrong thing in your notes. So cosine is normally adjacent over hypotenuse, but in this case, we would use x and r. Secant is the reciprocal, so that would be r over x. Tangent, opposite over adjacent, but in this case, that's a y and an x. Cotangent is the reciprocal, so that's an x over y. That y looks janky. Let me move it. Fix it. There we go. All right. So if you're given an ordered pair, you can find that, you know, the x, the y, you can find the r, plug it in that way instead of having to use o's, a's, and h's. This is also going to help us out because we're about to figure out, depending upon which quadrant we're in, is our sine, cosine, tangent going to be positive or negative? Okay. Because our x and our y aren't positive all the time, are they? If I'm over in the first quadrant, or I mean second quadrant, my x is now negative. So anywhere that I have an x, that would be a negative number. If I go in the third quadrant, x and y are both negative. So anywhere that there's an x and y would be x or y would be a negative number. So that's going to change the sign value, like SIGN, of the trig functions. Okay. Fourth quadrant, you've got a positive x and a negative y. So that's going to do that as well. So we're going to draw another coordinate plane. And in this one, we're going to specify, is sine positive or negative? Is cosine positive or negative? And is tangent positive or negative? So you'll have that to reference when you are looking at this, okay? Because the sine of 60 degrees in the first quadrant is going to be different than the sine of 240 degrees, which is in the third quadrant, because of the positivity and negativity of it. We have to pay attention to that when we are evaluating our trig functions, our ratios. So now we'll do our sines. So we're using these fractions, and the fact that we know, like, a positive over a positive makes a positive, a negative over a negative makes a positive over a negative is a negative, things like that to evaluate. These are the quadrant numbers, and next to that, I'm just going to write the signs of the x value and the y value. So the ordered pairs next to it, it's just if x is positive or negative and y is positive or negative. So in quadrant 1, they are both positive, right? You agree with me? All right, quadrant 2, x is negative and y is positive. All right. Quadrant 3, they are both negative. In quadrant 4, x is positive, but we're underneath the x-axis, so y is positive. I mean negative, sorry. I just wrote sine, cosine, tangent in all 4 of the quadrants. I don't have to write all 6 trig functions out because if you know what sine is, if it's positive or negative, cosecant has to match because it's just a reciprocal. It's just flipping it over. So if that's positive, this one also would be. If this was negative, this would also be negative. So I only put the first 3 trig ratios in there. Okay. And something else for us to note before we write down our positivity and negativity is that R is always a positive number. So if you think about it, if you are plugging numbers in, it doesn't matter if X or Y are positive or negative because when you're evaluating it, you're squaring them, right? And what type of number do you always get when you square something? A positive squared is a positive, right? A negative squared is also a positive. So if I add 2 positives together, is there any way that R could be a negative number? No. So that's also important to note. I'm just going to put it in a little box. R always, we put the L in there, always positive. So when we're going through trying to figure it out, that's important to know. Anywhere we see an R, that is a positive number. I'm going to help you guys with the first 2 quadrants, then you guys will fill out the second 2 quadrants. So our first quadrant, we're going to do sine. Sine is Y over R, okay? In the first quadrant, sine is positive, yes? R is always positive. So a positive number over a positive number makes a positive. So in the first quadrant, sine is positive. So we see what ratio we're looking at and determine in that quadrant, are those numbers positive or negative, and then divide them, okay? So cosine, X over R. In the first quadrant, X is positive, R is always positive. A positive divided by a positive makes a positive. Okay. Tangent is Y over X. Y and X are both positive. Positive over positive makes a positive. I bet y'all are thinking, are we ever going to get a negative? Yes. Just not in the first quadrant. In the first quadrant, every single thing is positive because we don't have any negatives to deal with. X and Y are both positive. All right, so we're scooting over to quadrant 2. Okay? We're looking at sine. Sine is Y over R. Y is positive. R is positive. So what is sine in the second quadrant? Positive over positive makes a positive. Good. Cosine. X over R. What is X in the second quadrant? What type of number?
Negative.
X in the second quadrant is negative. So a negative over a positive is a negative. So cosine in our second quadrant is negative. That was our first negative number. Tangent, Y over X, which is a positive over a negative. Positive over a negative makes a How can you show me with your hands? Mouth it. I don't care. Positive over negative is a negative. Good. Okay. So I want you to follow that same process and fill out the remaining coordinate plane of the sine, cosine, tangent. So do third quadrant. X and Y are both negative. So think about what it would be. Fourth quadrant, X is positive, Y is negative. So go through and fill that out, and then we'll make sure that you got it. All right, when you finish, go ahead and show me your paper. I need to see all of your papers that you have filled out these pluses and minuses. These are hard to see, they're so small. All right, I'm seeing some that are good. Some just have a little bit of an error. You'll be able to fix them then when we go over them. But good. Good. I want to make sure I'm seeing papers from everybody that you've attempted this. Thank you. All right, so if you are just laying on your bed texting, make sure that you are writing this stuff down and filling these things out so I can check and make sure you're getting it, that you know what's going on. All right, all right. Now, Joe, I think you're frozen. Or just very still. Okay, good. All right, you can put it down if I saw it. I saw. Okay. All right, so let's see. We had a negative for X and Y. So for sine, negative over a positive makes a negative. Cosine, negative over a positive makes a negative. Tangent, negative over a negative. What's a negative over a negative make? A negative divided by negative is a positive. So in the third quadrant, your tangent should be positive, everything else negative. So go ahead and double check. I know a few of you put negative on the last one. So look at that. It should be negative, negative, positive. If you need to fix it, please, so you don't have the wrong thing in your notes. Okay. Fourth.
Ms. Roselle, can you explain how you got that?
The positive. If you divide a negative divided by a negative, it's like multiplying the two negatives together, and it makes it a positive.
Which ones are negative, though?
X and Y in the third quadrant. So it'd be like negative over negative for the Y and the X part. In the fourth quadrant, the only thing that's negative is the Y value. So we'll think about that. Negative over a positive is a negative. Cosine, so that's X, positive over a positive, and that makes a positive. And tangent would be Y over X. Y is negative, X is positive. Negative over positive makes a negative. So the only thing that is positive in the fourth quadrant is cosine. Okay. All right, most of y'all got those. You might have just missed like one of them. So double check and fix it if you got it wrong on your page so you don't have the wrong thing. The way that most people remember these signs is we don't go through and do this every single time. We're not like, oh, this is the fourth quadrant, I'm going to have to write all my things out. Most of us just memorize this, okay? we just write down what is positive in each quadrant and remember that and know everything else is negative. Okay, so in the first quadrant, everything is positive. So I put an A and that stands for all positive. What's positive in quadrant 2? Just the sign. So I just put an S. That's the only thing positive in quadrant 2. So A, S. In quadrant 3, it's the tangent that's positive. And in quadrant 4, it is cosine that's positive. So most people, when they're learning this, they just memorize ASTC. ASTC, you just say it a bunch. And I just write it down on there. So I know if someone said, what is the sine of 210 degrees? I could just go to 210. Well, tangent's positive there, so that means sine has to be negative. Okay, so I just memorize ASTC instead of having to make all of this stuff every single time. And remember that if it's secant, secant goes with cosine, those match. If it's cosecant, that's the same as the sine, and tangent, that's the same as the cotangent for those. So we'll have to put together whether the trig function is positive and negative, and also we have to use what's called a reference angle. So those are the two things that we're going to have to use now to figure out our trig functions of things that are more than 90 degrees. Our 120s, our 240s, our 5 pi over 6s. Our reference angles can only be between 0 and 90 degrees. What the reference angle is the angle that we would make if we drew our triangle by going to the x-axis. So that's how we are going to find our trig ratios, is by having the triangle. So we need to know what that angle is in that specific triangle. So I'm going to draw four situations, and we'll see what our reference angle is going to be and how we find that reference angle. So reference angle specifically is the angle that is made when you go from the terminal side to the x-axis, whether you have to go down or whether you have to go up to make your triangle. We'll do degrees reference angles first, and then I will show you how I do reference angles when it's in radians. For some of them, the ones that we're going to use, there's just a little trick that works every time. But for more obscure ones, I'll show you what I do for those. There's lots of different ways you can find it, but I'll show you what I think is the easiest one. Okay. So what we're going to do now is we're going to do this on all of the angles that we have. We're going to go ahead and make our right triangle. So I'm going to go from our terminal side to the x-axis to make the right triangle that we're going to be looking at. Okay, and then we'll figure out what the angle was actually going to be in there in a second. So on our first one, here's our terminal side. I'm going to go straight down to the x-axis. This is my right triangle that I will be using for my trig ratios. Okay. So now go to the second one. You're going to go from your terminal side or your terminal point. That's that point right there. You're going to draw a line straight to the x-axis. The triangle that we are looking at is from the x-axis, this line, and this here. So I'm going to put that in yellow so we can see specifically this is the triangle that we're going to be using. Are we okay with that so far? You just go from your point, you're going to go to the x-axis. That's going to make a triangle, and we're going to use that triangle. Your angle is always the one that is close to the center, so I'm going to label that as the theta that we want. That's hard in the yellow. Can y'all see the yellow at all? Little? Let me use a different color then. I'll put purple in there. That's the angle we're looking for, theta. Okay. All right, now we're going to go to the next triangle. You're going from the terminal point. You're going to go to the x-axis. So we can't go down to the x-axis because it's above it. So you're going to go straight up to the x-axis. You draw your right angle. This is the triangle we will be using. The angle we want to find is the one that's on the inside here. Oh, that's too thick. Here we go. That's the theta, this part right there. Okay. And our last one, go to your terminal point, your last point. You're going to go to the x-axis. This is the triangle that we are using. And here is the theta that we want right in here from that wedge. Oh, I forgot to label theta in the first one. That's theta. So the reference angles are these thetas that we want to figure out. We want to figure out if we drew this triangle, what would that angle be in that little wedge, either here, 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 or here, depending upon which quadrant we're in. Okay, so I'm going to have y'all help me figure out. Actually, take 1 minute and see if you can figure out what those angle measures are. Just think about where it is, how much has already gone around from your angle. So write down what you think the thetas are for all 4 of those angles. So give it a shot. The first one's easy, it's just 60. About 20 more seconds for you to kind of think about it. How would you figure it out? All right, so on our second one, raise your hand if you think you know the answer to what this angle measure would be in our second graph here. Got a couple people. Oh, you hit the raise hand button? Oh, that was Elijah. Sometimes it's hard to see. Elijah, what do you think? Well, there's two Elijahs now in the class. But
is it 45?
It is 45. How'd you get 45?
I did 180 minus 135.
Right, because this little wedge, our little theta here, and the 135 together make 180, which is our straight angle, right? So you can just say 180 minus 135, and that's going to give us 45 degrees. So our reference angle is 45 degrees. So when we are using our trig ratios, we're not going to use 135, we're going to use 45. Is 45 one of the angles we know that we've used in our special right triangles? Yep, so that's good for us. All right, raise your hand if you think you have the answer for the little theta here in number 3. If you think you have the answer for that. Hand up, Caitlin. Caitlin, what you got?
Would it be 60?
I think it'll be, oh, did you subtract it from 270?
Yes.
Okay, so think about that. 60 is this part on the outside right here. Okay, because if you had said you had only subtracted that part from 270, you would have gotten this wedge, but you wanted this part here. Okay, so if you take 210, the whole 210, and subtract 180 from it, are you just left with whatever's in this wedge here? Yeah, so you're going to take the whole 210 and take the 180 out, and you'll have theta. So 210, I'm going to take it away 180, and 30 degrees is going to be my reference angle. Anybody get 30 degrees on that third one? Thumbs up if you did. You got 30? Okay. All right, and now on our last one, we have 310 to get to here. What would be this little wedge? You want to give me, Deborah?
I got 50.
50 degrees, good. Because you need 50 more degrees to get to 360, right? Is that what you did?
Mm-hmm.
Yeah. So 360 minus 310, and that is 50 degrees for our reference angle. Okay. Occasionally, you will be asked about reference angles that aren't originally from 0 to 360. Then you have to do like coterminal stuff. So if someone said, if our original one was like 700 or something, or 750, if they said, what is it for 750? The reference angle, you're not going to be able to just look at it on there. So how do you figure out if you have 750, what it would be from 0 to 360 before you start working on that? You do your coterminal stuff. So if it's not just original 0 to 360, you would subtract until you get down to that. So minus 360, I think we have to do it 2 times. Minus 360, that's going to equal 30 degrees. So if it's not from 0 to 360 originally, you either add 360 till you get there or subtract 360. You do your coterminal stuff for those. So if you have one of those on there, just to give you a heads up if that happens. Okay. All right, and here is how we do it if it is in radians. The only radians I will ever give you and ask about reference angles are pi over 6, pi over 3, and pi over 4. And just the way that it works, because they don't repeat in a quadrant, the way that we have them written, it's really easy to do. And here it is. This is if it's in radians. It only works for our special ones that we use, but those are the only ones that we're going to do in here anyway. So if I had 7 pi over 3, or 4 pi over, I don't want to do 4 pi. Let's do 5 pi over 4. instead. Or if I had negative 7 pi over 6 and someone said, tell me the reference angle for these, you could switch them into degrees and figure it out that way. But if you got just pi over 3, pi over 4, pi over 6, because of the way they work out, this is our reference angle. Pi over 3 for that one. Pi over 4 for this one. Pi over 6 for this one. So if you have it in radians and your radians are a pi over 4, 3, or 6, the reference angle is just whatever that is. You just ignore our number in the front. This will give us a number that's between 0 and 90. So our reference angle for this one is pi over 3, which remember that is 60 degrees. This one is pi over 4. Remember that is 45 degrees. And this is pi over 6, which remember that is 30 degrees. If you have some other kind of denominator, you would switch it into degrees first and then do it. But if it's one of our special ones, you just truncate or cut off the first number, and then what you have there is going to be the angle you're going to look at. All right. Now we are ready to put 2 and 2 together. We're going to put together what's the reference angle, and is it going to be positive or negative? And that's how we're going to figure out what is sine of 120, what is tangent of 240, numbers that are bigger than 90. Okay. And if you are given things that are in radians and you don't know what quadrant it's in, always put it in degrees and you can figure it out easier that way. Actually evaluating. So all of the ones that we're doing are multiples of 30, 45, or 60, because those are the ones from the special right triangles. So if we are evaluating these trig functions, we have just a list of things that we've got to do before we can get the answer. So to evaluate our trig functions, we first figure out what quadrant is it in, and in that quadrant, is it positive or negative? So we look at our ASTC, whether it's tangent, sine, or cosine, okay? The second thing we do is we figure out what the reference angle is. And the third thing we do is we say, okay, I know what the reference angle is. Now I'm going to go look at my notes from our special right triangles. And depending on if they were asking for sine, cosine, tangent, whatever, you would write down what that trig function was for that specific reference angle. So all of these are going to be 30, 45, or 60 for the reference angle. So they're all going to be on those notes. Okay, then we put together what is that number, and is it positive or negative, and we have our answer. So if you don't have the notes from last time, you'll want to get those written down. Also probably watch the video. So we'll do 2 examples. So the first thing we want to do, we have sine of 135. What quadrant are we in for 135? We are in the second quadrant, right? It's between 90 and 180. So we know we're in quadrant 2. Okay, so we're in Q2. In quadrant 2, is sine positive or negative? So go back to where we have it written down. We're in quadrant 2, sine is positive. So our answer is going to be a positive answer. So I'm going to write, I was in quadrant 2, so I know my answer is positive. Okay. Now I'm going to look for my reference angle. I normally draw the picture until I get used to doing this a bunch. So once I know 135, I'm here. This is 135. I'm looking for this wedge down there. That's how I would make my triangle. I want to know this part. Okay, so if that's 135, what would this little wedge be? I think we did that one already. It would be 45, right? So I have to figure that out, and I did that by saying 180 minus 135, and that is 45. So my reference angle is 45 degrees. Okay, so that was step 2. Step 3 is to figure out what is the trig function of that reference angle. So what is sine of 45 degrees? So they're asking for sine. So we want sine of 45 degrees. So I go back in my notes. I flip back to what we did last time. I look on the special right triangle part, right? So I look on here. I see my special right triangles. Go to 45 degrees. What is sine of 45 degrees? Root 2 over 2. Okay, so that is root 2 over 2. And I'm going to put them together. I always do this even though it's kind of redundant, but I want to make sure I have the right sign if it's positive or negative. So my answer is positive root 2 over 2. So sine of 135 degrees is positive root 2 over 2. So is it positive or negative based on the quadrant? What's the reference angle? Use your notes from last time to figure out what the ratio is, then put together the positive or negative with that ratio. Okay, we're going to try another, and then that'll be the last thing. Actually, we have a formula to all just write the formula down for you to use after this, but we'll not do an example of it. So we're going to do, let's go with, trying to do the same ones I have on the notes that I already posted. Cosecant of 7 pi over 6. What quadrant is 7 pi over 6 in? Anybody have an idea? Would it help to know what that was in degrees? Okay, so I'm going to show you guys a shortcut to figure out what the degrees is if these are pi over 6s or 4s or 3s. Okay, what is pi over 6? Pi over 6 is 30 degrees, right? How many pi over 6s do we have in this problem? 7, right? What would 7 30 degrees be? 7 times 30 is?
210.
210, right. So this is the same thing as cosecant of 210. So if y'all ever wonder, like, how do I get them so quick? I just go, oh, that's 30 times 7, 210. If it was pi over 3, I would just say 60 times whatever and get the number. Okay, so cosecant 210. So I'm going to go ahead. So all of you guys that said it was in quadrant 1, let's backtrack. And what quadrant would it be in? Quadrant 3. Okay, so Q3, cosecant Q3. Q3. We're going to check out Q3 for cosecant. Quadrant 3, cosecant. It doesn't say cosecant up here, but cosecant matches with sine, right? They're reciprocals. It's got to be the same as sine. So it's going to be a negative. Okay, cosecant and sine match. So because it's in Q3, we've got a negative answer. The next thing we find is the reference angle. You're welcome to draw the triangle, but since they gave it to us in radians, it's kind of helpful. I can just go like this for my reference angle. Pi over 6, or how many degrees? 30, right? Pi over 6 is 30 degrees. Reference angle is 30 degrees. You could draw your picture and do 210 and subtract. We did that one already, and that would be 30. Now we're going to say, what is cosecant of 30? Go back to last notes.
Okay, Miss Roselle, you keep saying, like, go back to last notes and find that. Where are you looking? Because I cannot find that.
So you know where we wrote special right triangles?
Yes.
And it has like, for 45 degrees, it'll say like sine of 45 equals this, cosine of 45. That's where we're looking. So go to the 30 degree section right now.
Okay, got it.
We're going to look at cosecant of 30. Yeah. So those 3 sections, the 30, 60, and 45 is what we're looking at.
I have a question. So do we
Yes.
turn it into a -2?
Yeah, the answer is going to be -2 for the final one. So cosecant of 30 is just 2, right? We all saw that. So cosecant of 210, or 7 pi over 6, is equal to, put them both together, -2.
Ms. Roselle, can you explain where we got 210 from?
Yeah, you could put 180 in for pi. 7 times 180 over 6 is 210. Like switching from radians to degrees. But in my head, I do it like this. Pi over 6 is 30, right? And 30 times 7 is 210. You can do it that way too. So positive or negative, what's the reference angle? Look at your notes from the other day and put together the sine and whatever that ratio is. All right, your first couple problems on your homework are just like what quadrant things are in. So you're just thinking about doing coterminal angles and subtracting or adding, and you have some reference angle stuff, and then it goes on to these problems. The bulk of it are problems like this though, where you have to figure out the quadrant, figure out the thing. So go ahead and get started. You've got about 13 or 14 minutes. You should finish the first 5 or 6, no problem. But if you've got questions on those. Oh, the formula for area of a triangle, I forgot that. So sorry. Apologize. So this is a weird formula. I don't know why it's in this section. It doesn't really fit, but I guess it didn't have its own. It's only the area of a triangle if the triangle that you have looks like this, and you know the angle in between 2 sides that you know. So if you know 2 sides and the angle in between, you can use this special formula area equals 1/2 A times B times sine of theta. So you just plug in the numbers of the two sides and you plug in sine of whatever angle they give you that's in the middle. So you don't have to have like a base and a height if you know the two sides and that included angle. So just plug the numbers in for that. Make sure you're in degrees.